Alright, John, so hopefully this is going to work a little bit better because my computer's not doing as many things at one time now. So, let's see. Alright, so we just did this problem. Okay, if sine theta is equal to negative 2/3 and tangent theta is greater than 0, find out what cosine theta is. Okay, so there's two different clues that it's giving us right now. It's telling us that sine theta is negative and that tangent theta is positive. So the reason why it's giving you those two pieces of information is so that you could figure out what quadrant you're in, so you know if cosine is going to be positive or negative. Okay, so sine is negative, meaning that we're not here and we're not here, and tangent is positive, meaning that we are lying in the third quadrant. So whatever cosine theta is, it's going to be a negative value. So the first step that I would have you do is write out cosine theta is equal to, and then just write a negative sign next to it so that you don't forget that in the future. Okay? And then it also gave us two other pieces of information. We know that the opposite side is 2 and that the hypotenuse is 3. Now, the negative 2 just tells us which quadrant we're in. When you're going to put these values into the Pythagorean theorem to figure out what the adjacent side is, don't put in negative 2. I mean, technically it won't matter because when you square it, it's going to become a positive 4 anyways. But the negative really just tells us which direction that we're going in. But the length of the side of a triangle is distance. So a distance is always positive. The negative just really tells us where we are. Okay? So cosine theta, we know that the hypotenuse is 3, and we have to figure out the adjacent side. So we're going to do 2 squared, go away, plus x squared is equal to 3 squared. So 4 plus x squared is equal to 9. So that means that our x squared is equal to 5 and x is square root of 5. Okay? So in this case, the fact that it's a square root, it really doesn't have that much of an effect on anything because the square root is up in the numerator. However, if this same question wanted us to figure out all 6 of the identities, sine, cosine, tangent, cosecant, secant, and cotangent, and we had to flip that over to figure out the reciprocal, that's when we would see a problem and you'd have to do something. But the answer to this is just negative radical 5 over 3. Okay? Alright. Write each expression in terms of a single function. Now, this is the kind of stuff that I was talking about. This is the kind of questions that use the identities. That's why I didn't understand why she was asking you those other questions first. So before we answer that, let's just go back and review the identities really, really quick. So we know that cosecant is 1 over sine. Secant is 1 over cosine. Cotangent is 1 over tangent, which we really won't use all that much. We're going to use the quotient identity more often than this one, but it's just helpful to know where we get it from. Tangent is equal to sine over cosine. Cotangent is cosine over sine. And then we had those Pythagorean identities, and the first one is the easy one that you need to memorize. Sine squared theta plus cosine squared theta is equal to 1. And remember how we can rearrange this? We can really rearrange any of them by just subtracting things from one side and moving it over to the other. So I'm not going to write out those other two versions, but we did go through and derive another set of 2 equations that we can get from this one. First thing we did was divide through by sine, and we got 1 plus cotangent squared theta is equal to cosecant squared theta. And then the second one, we went through and we divided everything through by cosine squared theta. So we got a tangent squared theta plus 1 is equal to secant squared theta. And like I said, these will not be given to you on the test. Tell Abby that you can't have anything written down in front of you, but what you can do is memorize that top one, and then as soon as you take the test right on top of the paper, just go through and divide through by sine, divide through by cosine, and derive the other ones. A lot of kids just had a sheet of paper blank next to them, and they did all that stuff before they even started. Okay, so here are all of our identities, and we're going to use those in the questions right here. Okay, so write them all in terms of a single function. Well, cosine and sine are our most basic elements. Every one of the other functions, we can break them down in terms of sine and cosine. So cosine, we really can't do anything with it because it already is really a basic value. So we're just going to leave that as cosine theta. Tangent, on the other hand, we can rewrite in terms of sine and cosine, and I'm going to say that a lot. Can you rewrite that in terms of sine and cosine? Tangent, yes you can. Tangent is sine divided by cosine. So now that we're multiplying these two values together, is there anything that we can cancel out? And you should be able to notice that we have a cosine on the top, cosine on the bottom. So this whole thing is really just equal to sine theta. Alright? This is what a lot of the questions on your test are going to be like, rewriting things and rearranging things in terms of sine and cosine. Alright, the next one. Secant squared theta minus 1. And I have to rewrite that in terms of a single function. Well, I'm just going to go right here, take a look. The only identity that I have that has a secant in it is right here. And the question said secant squared theta minus 1. So if I subtracted 1 right here, minus 1, minus 1. On the right-hand side, I would have secant squared theta minus 1, and on the left-hand side, I'd have tangent squared theta. So secant squared theta minus 1 is equal to, whoops, wrong way. This whole thing is equal to tangent squared theta. Now, if you don't have that squared right there, then you're going to get it wrong, okay? Because secant squared theta minus 1 is not equal to tangent by itself. You need that squared. Now this is homework number something. 354, 1 through 11. This is homework number 81. So if you could do that and then give it to Abby to hand it to me, that would be fantastic. I'm going to take a minute, and I'm going to take a second in a second to go back and double check the ones that you did hand in to me, and I have a list of things that you owe me, but I'll talk about that in the next video. Right now I want to keep going because technically we would have 45 more minutes to keep working. Okay, so next one. More practice with identities. You're still going to be using those same identities that I wrote out for you before, okay? Alright, write each given expression in terms of sine and cosine, and express the result in simplest form. Same kind of questions that we had before. We're going to rewrite everything in terms of sine and cosine, and then kind of just simplify, cross things out, and see what happens. So how can I rewrite secant theta in terms of sine and cosine? Well, secant theta is actually the reciprocal of cosine. So this is actually 1 over cosine. And I'm going to multiply that by cotangent, and I can rewrite cotangent using the quotient identity. So this is what I mean by, we know that cotangent is 1 over tangent, but in this case that doesn't help us at all. Cotangent is actually the one where we have cosine on top, so cosine theta divided by sine theta. So hopefully you can see that those cosines are going to cancel out with each other, and what we're going to be left with is 1 over sine. Now 1 over sine, that's fantastic. We rewrote it, in a simpler form, but we want it in simplest form, and I know that we can rewrite 1 over sine as cosecant. And that way it's just written as one single function, cosecant theta. Okay? Let's try the next one. Multiplication and addition, or multiplication and division, those are the easiest ones because all you're going to do is rewrite them next to each other and then hopefully cross out things or do some sort of manipulation. Addition and subtraction, those are the hard questions. And the reason why is because we're writing everything in terms of fractions, and in order to add or subtract a fraction, you need to have a common denominator. So sometimes it's going to work out, sometimes it's not. So we have secant theta, which I can rewrite as 1 over cosine theta, plus tangent theta. Now, rewriting tangent in terms of sine and cosine, tangent is written as sine theta over cosine theta. So, what you need to ask yourself if you're adding or subtracting is, do I have a common denominator? And in this case, yes, I do. My common denominator is cosine theta, and then all you have to do is add together the stuff that's in the numerator. So this is 1 plus sine theta. Now, I want you to be really careful, John, because sometimes if you're dealing with questions like this, say this was secant squared theta plus tangent squared theta, then all of those things on the screen right now would all be squared, and you'd probably be able to simplify this just a little bit more in terms of the numerator if that was a sine squared. But because it's not squared, that's it. We're done. That's our answer. Okay? You would probably see something like this in terms of a multiple choice question on the test. And then let's do the last one. So when you are dividing this stuff, you're going to have complex fractions. You're going to have a fraction divided by a fraction. So you're going to have to multiply by the reciprocal. So I'll show you how to do that. So secant, yet again, is 1 over cosine. Hopefully you're memorizing these by now. 1 over cosine theta. And that is all divided by cosecant. And cosecant is 1 over sine. Now, I believe that we have done this together before, so I think that this is how you do it. You need to multiply, I know that this is how you do it. I think this is the way that you know it as well. So we need to multiply by the reciprocal, so I'm going to multiply by sine theta over 1 on the top and the bottom, because all that stuff is going to cancel. And up here I'm going to have sine theta divided by 1. So nothing cancels up top, so what I'm left with is sine divided by cosine. And sine divided by cosine can be rewritten as one single function, or in simplest form, and that is equal to tangent theta. Okay? So that's a really good indication of what you're going to see on the test. If you are okay with questions like that, then you're pretty good. They're obviously going to get a little bit more tricky, but so far so good. Okay, this is a question that's very similar to what we already did. They're just kind of mixing it up just a little bit by giving you what cotangent is instead of sine, cosine, or tangent. So I'm going to stop right now and then start a new video for you. Okay?